Hi, good evening. Welcome to Unacademy YouTube classes. Are you able to hear? Yes, right. Welcome everyone. Are you able to hear? Are you able to hear everyone? Voice? Are you able to hear now? Yes. So yesterday we have completed what electrostatic force of attraction, that is Coulomb's law, attraction and repulsion between charges, right? Now we will continue the force problems and some phenomena. So welcome everyone. How are you all? So who are watching, just a message here once. Let me know who are joined here. And see, these are the Unacademy Plus class subscription benefits, everything. So to get more details, you can just see the description, below the description. Complete details are there. You can watch and subscribe. And our special classes also daily from 6 p.m. to 7 p.m. there. Best classes are going on. So utilize this opportunity. Okay. Now, see, yesterday we had discussed what electrostatic force and square problem we have discussed. Four charges on square, four sides of the square. So see, on a square, four identical charges placed. That problem we had finished, right? Now we'll give you one more problem. That is, see, a charge Q is divided into two small parts. A charge is what? Q. A charge Q is what? Divided into two small parts. Okay? Divided into two small parts. Just wait, guys. 1 minute. Just 1 minute, guys. Forget to send the link. Just 1 minute, I will send the link. Okay. Right. Now, are you able to hear everyone? Yeah. Okay. See, a charge Q is divided into two small parts. Just wait, they're asking the. Okay, are you getting now? Yes. Kavya. Hi Kavya, good evening. Are you able to get my voice? Bharat Kumar, hi. I told you the YouTube class is alternate days. We have 4:30 to 5. This is just extra class for our promotion. Rekha, hi. Hi. And our class, evening class is as usual, same, 6 to 7. Yeah, good evening. Good evening. Yeah, hi. Rekha. Hi, Rekha. See, a charge Q is divided into, yeah, for YouTube, yes, for our classes promotion, we have YouTube classes. Alternately, I can take from 4:30 to 5, half an hour. Small topic I can explain. Where are you from, Rekha? Yeah. Okay. See, a charge Q is divided into two small parts. So, what is the value of the charges on part? Means, what is the value of charge? Value of AP. Okay. So, are you coming to our special classes in website? Value of charge when force is maximum. F is what? Maximum. So you can come to our special classes also, Rekha. Daily evening from 6 to 7 p.m. So you can join and from that, yeah. Okay, see. We have started electrostatics now in this YouTube class. In our special class, we have started first year revision. So now projectile case is going on, very important case. So join daily. And for all subscription details, see the description below. You will get. Okay. Okay, it's your wish, no problem. It's your wish. If you like na, you can like it. If you dislike na, dislike, no problem. It's your wish na. Without watching and without listening anything, doing that means once think it. Okay? Okay, leave it. See. This is what? So charge is what? Divided into two small parts. So find the value of charge when force is what? Maximum. So when the force is maximum, what is the charge? See, first of all, it is divided into two parts. See, let one part is Q. See, total is what? Capital Q. One part is small q. Then what about the remaining part? Capital Q minus small q. So if you add total Q plus Q minus Q, how much it is? Q only, na? So one charge, we have to divide like this. One charge is Q and the remaining will be Q minus Q. Okay. Now what is the force? See, these two are now separated by some distance r. So what is the force of attraction or repulsion? F equal to 1 by 4 pi epsilon naught. That is K. Right? Constant K into Q1, Q2. That is Q into Q minus Q by R square. Okay. Now, given that the force is what? Maximum. When will the force is maximum? See, generally we have the case when a quantity is maximum or minimum, it is said to be constant. So if you differentiate that constant, you will get 0. So that you can differentiate with respect to what? Charge Q. D by dq of F will be what? 0. When force is maximum. See, whenever a quantity is maximum or minimum, okay, now maximum or minimum, then whenever a quantity is maximum or minimum, its differentiation is what? 0, because maximum or minimum is what? It is constant. So constant value become 0 whenever you differentiate that. So d by dq, we are taking q now, so with respect to q we can differentiate. Okay, so differentiate now. D by dq of what is the force here? K into q minus q by r square and equate with 0. So k by r square is what? Constant into d by dq of, see, q into q minus q into q square equal to 0. See, this term will come this side, 0 becomes now d by dq of q into q minus d by dq of q square. It is equal to 0. It will come this side. Now differentiate individually. What will you get if you differentiate? See, d by dq of q, this capital Q constant. So d by dq of q is what? 1. So here the remaining will be what? Q minus, see this, d by dq of q square, d by dx of x power n is what? N into x power n, right? So 2 into q power 2 minus 1 equal to 0. So q minus 2q equal to 0, q equal to 2q. So therefore small q is what? Q by 2. So one charge is q by 2. And what about the remaining charge? Q minus q, that is q minus q by 2, that is q by 2 only. So therefore two charges are here what? Q by 2 comma q by 2. See, if you add these two, q only we are getting. So our answer is correct. So when the force is maximum, then each charge is what? Q by 2. So this is a method to find. Okay, understood? And here, see, in this electrostatic force, we have null points. Null points means where the net force becomes 0. Suppose here, see two charges Q1 and Q2. See, these two are like charges. Okay, so two like charges are placed at some separation D. Now, if the net force is 0 between the charges, if the net, suppose at a distance x from Q1, let us place a test charge or a point charge Q0. Test charge or point charge means what? It is a small charge, small part. So actually there is no effect of this. Okay. So when we place a small point charge at a distance x from what? Q1. Then here the net force is what? Balanced. So net force is balanced means what? The system is in equilibrium. Means see, force between any two charges is same. So net force here equal to 0. That means see, between these two, k into q1 q0 by what is the distance? X square equal to, take between these two, what is the distance? It is d minus x, right? So k into q0 q2 by what is the distance here? D minus x whole square. So k q0 gets cancelled. See, q1 by x square equal to q2 by d minus x whole square. So interchange d minus x whole square by x whole square equal to q2 by q1. So d minus x by x equal to under root of q2 by q1. Square will come this side. So you can write d by x minus x by x is what? 1. It is equal to under root of q2 by q1. So d by x equal to root of q2 by q1 plus 1. Anyone there? Boys? Nara? Arana? Bharat Kumar, Kavya? Are you following? So you can find what? X. So x equal to, this term will come this side. D by root over q2 by q1 plus 1. This is what? Null point distance from q1. If you want to find from q2, d minus x remaining. Okay. So like this we can find the null points. Null points. Okay na? Okay? Yeah. Are you following? Yes, very good. Yes. So this is what? Null points between like charges. Between the like charges. Now if you take unlike charges, see unlike charges. See q1, it is minus q2. If you take the unlike charges, then what is the null point distance? See, when we take unlike charges, then the null points will form beyond the line joining of charges, because see, in between cannot form. Why? In between, see, these two can attract, na? These two can attract, so that away from the line joining, null points will be formed. So where away from means towards the small charge. Suppose see here at a point P, at a distance x from the q1, null point is formed, means net force is 0. This is the distance d. Now again what? See, here we have to find charge q0, test charge. Okay. Okay now? Got it now? When you take like charges, the null points can form between the charges, between the line joining, because both can repel. But if you take unlike charges, now what happens? They can attract, so that null points can form away from the line joining, near to a small charge. Suppose see from the Q1 at a distance x, having point P, null point is formed, means we have placed a test charge Q0 here. Now what is the force here? See, net force balances now. See, force between these two, K into Q0 Q1 by x square equal to, between Q0 and Q2. See, K into Q0 Q2 by, what is the distance here? D plus x whole square. So again K Q0 gets cancelled. What is remaining? Q1 by x square equal to Q2 by d plus x whole square. So d plus x by x whole square equal to Q2 by Q1. So d plus x by x equal to under root of Q2 by Q1. So we can write what? D by x plus 1 equal to under root of Q2 by Q1. So d by x equal to what? Root of Q2 by Q1 minus 1. Okay. So x equal to d by under root of Q2 by Q1 minus 1. See, when you take like charges, the null points are what? Null point distance is d by root of Q2 by Q1 plus 1. And if you take unlike charges now, so null point distance x equal to what? D by root of Q2 by Q1 minus 1. So that generally we can write x equal to d by root of Q2 by Q1 plus or minus 1. Plus is for like charges and minus is for what? Unlike charges. Plus is for like charges and minus is for unlike charges. Okay. So what is null point? Where the net force 0 or forces are what? Said to be balanced, means the system is in equilibrium. System is in what? Said to be equilibrium. Then we will get the null point. Null point means where the net force becomes 0. That point is called null point. Means their force becomes 0. Net force. That means total forces are said to be balanced, equal. So like this we will get the null points. Okay now? So clear? Is it clear? So always for like charges mean null points can form in between the charges, and for unlike charges what? Null points can form away from the line joining and near to the small charge. Okay. Now see, due to these null points, I will give you one problem. See, two charges, 2 microcoulomb and hi Ashish, good evening. Good evening Ashish. Hi. See, here two charges, 2 microcoulomb and Q2 is what? 1 microcoulomb are placed at a distance 10 centimeter. D equal to what? 10 centimeter. So where should a third charge be placed? Where should a third charge be placed so that it does not experience a force? So that what? It does not experience a force. See, two charges, they are separated by 10 centimeter distance. So that what we have to place? See, Q1, Q2 having 10 centimeter separation, 2 microcoulomb, 1 microcoulomb. So where should a third charge is placed? Suppose at a distance x from 2 microcoulomb. Test charge is Okay, it is placed. Then the net force becomes 0. So what is that null point distance? And the x find GL. How can we find x? Directly we can find na. See, you are taking from first one. See, this is q1, this is q2 na. So like charges means x equal to what? D by under root of q2 by q1 plus 1. So what is d here? 10 by. What is q2 here? 1 by 2 plus 1. So how much it will be? How much it is? So find this value. Okay, 10 by 1 plus root 2. Here root 2 will come here. So 10 root 2 by, see, root 2 is 1.414 plus 1, that is 2.414. So this is a null point distance from x, from 2 microcoulomb. If you want to from 1 microcoulomb, just minus it. Okay, now. Or otherwise, see, if you take from 1 microcoulomb, distance from 1 microcoulomb, see, if q1 equal to 1 microcoulomb, q2 equal to 2 microcoulomb, means we have taken x is from here. In that case, see, generally in exam, they can ask from one charge, they can mention. Means they can ask from 2 microcoulomb or from 1 microcoulomb. Like this they can ask. So if you take q2, this is q1 and this is q2. In that case, null point is what? D by under root of q2 by q1. 2 by 1 plus 1. That is 10 by root 2 plus 1. What is root 2 here? 1.414 plus 1, that is 10 by 2.414. So this is what? 4.1 centimeter. This is 4.1 centimeter from 1 microcoulomb, right? From 1 microcoulomb. So remaining is what? 10 minus this. There 5.9. So E value ento vastundi? 5.9 centimeter from 2 microcoulomb. If you find one value, you will get the another value. See, you can take, if they don't mention from q1 or q2, you can find both. So whatever the option in given options are there, in that whatever the correct option, you can select that. That means, see, 5.9 centimeter from 2 microcoulomb and 4.1 centimeter from 1 microcoulomb. So which is correct here? Both are correct. If you take from 2 microcoulomb, this much, or 1 microcoulomb means this much. So these two are correct. Suppose if they ask from 2 microcoulomb, this is answer. If they ask from 1 microcoulomb, this is answer. Okay, now. So like this we have to find. So this is a method to find what? Null points. Null point distances finding. Okay. And still we have more problems. So just I will give you one problem, you can try this. Same yesterday we have done this square problem based on that. Because now time is not there, time is up, only just half an hour class. And again we have day after tomorrow. And day after tomorrow I will tell you, just you can try this problem, I will give you. See, a square, 4 identical charges are placed on 4 corners of a square. Placed on 4 corners of a square. So find the charge which is placed at the center. Find what here? A new charge is placed at the center, so that total system is in equilibrium. Total system is in equilibrium. So find that Q value. Find the Q value. Okay. See, 4 identical charge. Each Q is what? Placed at 4 corners of a square of side A. So find the charge to be placed at the center of the square, so that the system of charges in equilibrium. The system is in equilibrium. when we place a charge capital Q at the center. So whenever it is in equilibrium, find this Q value. So just you can take total force, find force at any one corner, because total force is similar. Find at any one corner equate with 0. You will get the Q value. So you can do this. If you don't get that, I will explain you in next class. Okay. So again we will meet in day after tomorrow class. Okay na? So bye all of you. Have a nice day.